Hello and welcome everyone. This is Mohammad Izamam from Saimedha Ecet Coaching Center Koti, Hyderabad. Saimedha Koti, Hyderabad is providing a golden opportunity to all the Ecet 2024 and as well as Ecet 2025 students. ఎవరైతే ఫైనల్ ఇయర్ లో ఉన్నారో, ఎవరైతే థర్డ్ సెమిస్టర్ లో ఇప్పుడు చదువుతున్నారో, Saimedha Koti, Hyderabad is providing the online coaching and as well as offline coaching for it. Ranks గురించి చెప్పాలంటే Saimedha Koti, Hyderabad లో every single time, every single year we have proven that maximum ranks in all the branches EC, EEE, mechanical, civil and computer science లో top 5 branches లో state first rank తో పాటు maximum ranks in top 10 and top 50 లో కూడా maximum ranks are there. In this video lecture series in the YouTube, we are going to be updating every single day for all the branches subject wise and as well as topic wise. Previous Ecet examination questions will be explained by expert faculties. My dear students, gurtu pettukondi, only previous year competitive examination questions korake separate course untadi, pay cheyalsi untadi baita market lo, kani Saimedha Koti, Hyderabad lo free of cost we are providing that series guys in this very YouTube channel. So those who have not subscribed the channel, subscribe now and press the bell icon to be notified for the further more updates. Every day subject wise, topic wise, previous Ecet examination questions with which you can understand the level of teaching, the expertise which is there in the Saimedha Koti, Hyderabad. So my dear students, what are you waiting for? Start watching all the video series in this YouTube channel. At the end of the video, I'll be coming back to give you a surprise for all the Ecet 2024 and Ecet 2025 aspirants. So share this video as much as possible for all the final year students and third semester students. Now let's start the video.
Hi, hello everybody. This is your Venkateshwar Naik from Saimedha Coaching Center Koti, Hyderabad. Hope all of you are doing well. Now we are going to see the Ecet PYQs of the chapter Leveling and Contouring. So if you see the very first question, if the RL of the benchmark is 200, backside reading is 1.5 defined, the foresight is 3.285, RL of the forward station is dash. The very first thing is here, first of all, try to figure out, that means try to draw a figure from the given data, right? So this is a benchmark. RL of benchmark is 200, where the backside reading on the benchmark is given here as 1.525 and the foresight is 3.285. Now he is asking us RL of the station, right? RL of the forward station. Okay, so very simple here. This is 200, right? So this is 200. So 200 plus 1.525 minus 3.285 will be giving me the answer. Why? Because backsides have to be positive, foresides will be negative, because here no inverted staff was there, right? Okay, so you can take the direct values here. 201.525 minus 3.285. So if you subtract this, 201.525 minus 3.285, so this is, if you solve, this is 0, 8, this is 4, this is 4 minus 2, this is 2, so 240. Any answer? So directly I will be taking this 198.240. Okay, so this will be the correct answer. Okay, so this RL here is 198.240. Very simple and easy equation, right? Moving further, the method of finding out the differences in between the elevations, 2 points eliminating the effect of curvature and refraction. So curvature and refraction will be observed only in the case of a reciprocal leveling. So direct answer here, reciprocal leveling, fine, easy. The surface of zero elevation around the earth which is slightly irregular and curved is known as, so this is a geodic surface, because whenever you see the earth's surface when it is completely filled with water, for example, okay, whatever the surface that this outer surface, occupies, we do call it as a geodic surface. Okay, simple. Next, the fixed point of known elevation is called benchmark because it is a point of known elevation. An invert is taken when the point is above the line of sight. See here, now this is the line of sight, this is the line of sight, and if I want to find out the RL of something called roofs, if I want to find out the RL of roofs, it is not possible for me, because here, see, I won't be able to touch this one, I won't be able to touch this one, okay. So if this is beyond this line of sights, whatever the height that is there here, if it is beyond this line of heights, then I will be going for this invert staff reading. That means here I will be inverting the staff here like this, so that I will be able to read and I will be able to reach the top. Okay, so that's what the very simple point is here. Above, it is not below the line of sights, it is not having high elevations, it is not inclined angles, right? So it is not below the line of sights, it is above the line of sights. Yeah, fine, it is above the line of sights. Now next, moving for the next question. Due to the curvature of the earth, the object looks lower than its original position. original position, looks lower than its original position. So this is the Earth's curvature. Okay, if you are observing this one here, maintaining our station here, so obviously this will be lower than this original position. So looks lower than its original position. Fine. The angle of intersection of a contour and ridge line is 90 degrees. Direct object equation. The technique used to cross a deep gorge or wide stream while maintaining the continuity of leveling. Wide stream, the technique of using a deep gorge or wide stream while maintaining the continuity of leveling. So generally continuity of leveling will be carried out in fly leveling. So to cross a deep gorge or wide stream, so while maintaining the continuity of leveling. So generally the continuity of leveling will be observed in fly leveling. So the option for this is there is nothing called radical leveling. Profile leveling will be observed for these alignments. Okay, reciprocal leveling, a technique used to cross a deep gorge, or wide stream while maintaining the continuity of leveling. So here he maintained a water body. Okay, he mentioned a water body here. So whenever a stream comes into picture, a wide stream comes into picture, then we will be going for reciprocal leveling, because in this wide stream there might be a chance of having these errors that is caused due to the curvature and refraction. So the correct answer for this question is reciprocal leveling, not the fly leveling, right? Because generally fly leveling we won't opt when any deep gorge or wide stream coming into picture, right? Moving further, the sign of combined correction for the curvature and refraction for an angle of an elevation. So the combined correction, generally the curvature correction is negative, refraction correction is positive, so the combined correction here is negative. Why? Because the curvature value is here high, this is 0.0785 d square, okay, and the refraction is 0.0112 d square, this is positive value. If you solve these, so that you will be able to have a negative value, that is 0.0673 d square. So this is what the resultant. Okay, so that's why the negative value will be coming here. Okay, so clearly negative. In the methods to reduce the levels, the method provides a better check on arithmetical work. So arithmetical work, that do mean that we have to calculate more number of checks. So that will be possible only in rise and fall method. Okay, it is rise and fall method, right? Because if you observe the rise and fall method here, the check for rise and fall method here, summation of backside minus summation of foresight is equals to last RL minus first RL is equals to summation of rise minus summation of fall. Okay, summation of fall. So here we are having an additional check here, so that it will be providing a better arithmetical check. So obviously the answer will be of option number 2. Fine. The staff reading taken on a point of known elevation is a known elevation. So known elevation is a backside reading. So the very first staff reading that you are taking upon a known elevation is nothing but a backside reading. Okay, simple, right? When consecutive contour lines runs close together, it indicates it indicates a steep slope. Right? The benchmark of a point is 100, and the backside of see here there is a benchmark, which the benchmark value is 100. Fine. Now what he says here, and the backside for the level staff on a point A. So backside on this staff. So here this is the leveling instrument, and here the backside reading was taken. The value came out to be here 2.325. Fine. Turn the telescope and measure the foresight of the B, which is 3.325. Calculate the elevation of B. So if I turn this telescope here, that means if I swing the telescope head, the value comes here is 3.325. Now what is the RL of this point, right? Calculate the elevation of the point B. So this is point A and this is point B. Now we are supposed to find out the elevation of point B. So very simple, as I have already done, this is 100 plus 2.325, because this is backside reading, which is always positive, minus that is foresight. So obviously this is negative. So if you solve this, you are going to get this answer. So this is 102.325 minus 3.325, right? So this is 0 here, this is 102 minus 3, that comes out to be 99, right? 99 meters. 100, 102, 103, yeah. So very simple. So 99 meters. Okay, so this is 99 meters. So obviously option 1 will be the correct answer. Moving further, what site is taken on a turning point of leveling survey? So on a turning point, you can observe both foresights and backsides. Okay. What is the nature of a terrain if the contour lines increase in elevation from inside to outside? So see here, for example, if I take a contour map here, now what he says here, the value increase in elevation. So the value of the RL value will be increasing from inside to outside. From inside to outside, the value has been increasing. Okay, that means here, for example, if I call this as 99 90, this is 91, this is 92, this is 93, this is 94, and this is 95. Okay. Now what is happening here, as we are going on inside, so as we are going on inside, the value is coming lesser. Okay, that do mean that this represents a depression, because when we are going inside a contour map, okay, when the values are increasing, that do represent it's a hill. Okay, but here the values are going on decreasing, so that's why this represents a depression. It's not a plane, it's not a ridge. Okay, so moving further, the staff reading on a floor of a veranda of a college building is 1.815, and the staff reading when held with the bottom of the staff touching the ceiling over the veranda is 2.870, RL of the floor is 74.500, height of the ceiling above the floor is. So very simple point here, this is the floor of the veranda, okay, which is having an RL of 74.50 meters. Okay, and here if I keep a staff and if I see the reading here, this is the leveling instrument, and if I observe the reading here, okay, floor here the value comes out to be 1.815, and see here this is a ceiling, okay, and there is a staff that is placed here, that is inverted staff reading will be observed because that is ceiling, and this reading here comes out to be 2.870 meters. Now what is the RL of, the question is height of the ceiling above the floor, he is asking only the height of the ceiling, right? Fine. So 1.815 plus 2.870 will be giving me the direct height of the ceiling. So very simple. So this is 5, this is 8, it is 16, 2, 3, 4, 4.685. So 4.685 will be the correct answer. Irrespective of this one, no need to take care of this one, because from here I need to start. So this is floor and this is ceiling. So total height can be 2.870 plus 1.815, direct objective question. In case of leveling the backside ease, it is a reading taken on a known elevation, right? So it is the first staff reading taken on the setting of the instrument. Okay, fine. So it is not a fixture, it is not a last staff reading, it's not any staff reading. Okay, because backsides have to be the very first reading that have to be taken after the setting up of the instrument, right? Moving further, a contour may be defined as an imaginary line passing through the points of equal elevation. Simple. Okay. Moving further, the reduced bearing corresponding to the whole circle bearing. So the reduced bearing corresponding to whole circle bearing of 180 degrees. So 190 degrees it will be lying in between the south and west. Okay, where this is whole circle bearing. Now he is asking us to find out the reduced bearing. So reduced bearing will be taken from the south. So this is 10 degrees and it is lying between south and west. So south 10 degrees west. Moving further, if the whole circle bearing is measured by prismatic compass is 120 degrees, its bearing measured by surface compass is. See here, whole circle bearing, generally whatever the reading that we are taking from this prismatic compass will be in terms of whole circle bearing, and whatever the bearings that we are taking with respect to surveyor's compass are reduced bearings. Okay, so very simply he is telling here is the bearing here is 120 degrees, so this is 120 degrees, and now he is asking us the reduced bearing of this line. So 180 minus 120, this value comes out to be 60, and it is lying in between south and east, so south 60 east, so that answer, right? Moving further, the procedure by which the refraction correction at the time of observation will be found is, single observation elevation, single observation depression, single observation very large distance, reciprocal observation. So generally see here the refraction correction will be observed only for the reciprocal observations. It is not any single observation at the elevation, it's not in depression, it's not single observation for a very large distance. Okay, so the procedure by which the refraction correction at the time of the observation will be found for is the reciprocal observations, right? Moving further, periodic variations in the level of a surface of a large body of water like a sea or an ocean are called. See, the tides, basing upon the tides here we are going to find out these elevations, we are going to find out the MSL, that is mean sea level. So periodic variations will be observed for the tides. Okay, so as to form this mean, okay, so that is tides. So here reciprocal readings were given here, so of which we are going to find out a correct statement from this. So if you see here, so this is the point that he is trying to express. This is the figure that I am trying to show you for this kind of figure. So here there is A and here there is B. Okay, the very first reading is 1.450. This reading is 1.450. Okay, and if I proceed towards, that is in leveling instrument at A and the staff reading at B, if I take from here, the reading is 1.695. So 1.695, that means here I have to reach a higher value. So when I will be able to reach the higher value, when this B value is at a lesser ground, when the B value is at a lesser ground, if the B value is at lesser ground, I will be able to get higher maximum values, right? I will be able to get higher maximum values, right? See here, I will be able to get the higher maximum value when this B value is lower than this A. That means A value is higher than B, right? A value is higher than B. So point A is higher than point B will be the correct answer. Simple, direct question. Moving further, a leveling station is a place where the level has been set up. The leveling station is a place where the level has been set up, right? The constant vertical distance between two adjacent contours is known as, so vertical distance is nothing but contour interval, vertical distance is nothing but contour interval, horizontal distance is nothing but horizontal equivalent, but he is asking us to find out the vertical distance, so the answer will be contour interval. It's not horizontal interval, it's not vertical equivalent, the answer is contour interval. Horizontal equivalent is for horizontal distance. Okay, so this is also not the correct answer, right? Moving for the next question. In leveling, the sum of all the back sides and summation of four sides are given respectively. The reduced level of the initial benchmark was given, the reduced level of the last point station. So we do know this check here, summation of back side minus summation of four side is equals to last RL minus first RL. Okay, so summation of back sides were given here as 8.7575 minus summation of four sides was given as 8.495 is equals to the RL of the initial benchmark. So first RL was given here, this is X, this is 100, right? So from here I am supposed to find out the value of X. Okay, so this is 8.575 minus 8.495, the value comes out to be 5 minus 5 0, so 997, so this is 8, I think it's so 9 10 11 12 13 14 15 16 17 here 8, so fine. So this is 0.080, right? 0.080, fine. So now this is 0.080, and if you see 100 plus 0.080 is equals to X, so the X value comes out to be 100.080, so 100.080 will be the correct answer. Simple question, right? Moving further, for a hilly terrain the ideal method of contouring is, the radial line method, right? If the distance between the instrument station and start station is 1 kilometer, the combined curvature and refraction. So if you take only for the curvature, the formula comes out to be 0.0785 d square. If it is only for the refraction, the formula comes out to be 0.012 d square. And if you see for the combined correction here, the formula comes out to be 0.06. This is 7 minus 1 6 8 minus 1 6 7 3 d square, right? Okay, now he is asking us to find out the combined correction for 1 kilometer. Just simply substitute the value of 1 there, the value comes out to be 0.0673 meters. So 0.0673 meters, and see it is negative, and it is negative, it have to be negative because combined correction is always negative, so this value comes out to be negative value here. Okay, if you see this 29th question, a set of closed contours with a higher value inward. So there is a set of closed contours with higher value inwards. As the value is going on increasing inwards, so this is for example 91, this is 92, 93, 94, 95, that do mean that the value is going on increasing, that do mean that this represents an elevated structure. Sir, how can you say that this is representing an elevated structure, sir? See here, if you project this, if you take this as a reference here 91, so this is a kind of structure. So if you just project this, okay, if you project these lines, okay, the value will be going on increasing because I am reaching here to the higher levels, okay. So if I project this, okay, obviously this kind of structure, it is representing an elevated structure, so the clear answer for this is an hill structure. Fine, a very simple hill structure, right? If you see the 30th question, the rise and fall method of leveling provides a complete check on rise and fall will be dependent upon the intermediate side. So intermediate side will decide whether that's a rise or fall. So the correct answer is intermediate side. The angle of intersection of a contour and a ridge line is 90 degrees. Direct object equation. In the leveling survey, the summation of all the back sides and summation of all the four sides are given here. So we do know the cross check. Summation of back side minus summation of four side is equals to last RL minus first RL. Now let us see the given values, all backside summation and the four side summation. This is 8.675 minus 8.595 is equals to the RL of initial benchmark. First benchmark is 100, so already we have solved this, I think it's so X minus, right? So okay, so 8.675 minus 8.595, this is 5 minus 5 0, this is 9 minus, this is 8. 9 at 17, so this is 5, this is 0, this is 0.080 plus 100, the value comes out to be 100.080 meters. So the x value here is 100.080 meters. So if you check 100.080 meters, okay. Which of the following statement is correct about the characteristics contours? Closed contour lines with higher values inside represents a pond. No. Closed contours with higher values inside represents a hill. Closely spaced contours indicates a plain area. No. Closely spaced contour lines indicates a slope. Contour lines intersect each other at right angles. Contour lines intersect. No. Contour lines won't intersect at right angles. Contour lines always form a closed circle within or outside the limits of the map. Yes. Yes, that's the correct one. Okay. So contour lines need not to be get closed within the map itself, but they have to be get closed at somewhere other than outside the map. So that's what the point that he's asking about. Okay, so contour lines need not to be get closed within the map itself, but the contour lines will be get somehow they will be get closed some outside the map. Yeah. If you see the 34th question here, a telescope is said to be inverted if it's generally when do a telescope is said to be inverted? See, generally for the telescope there will be a gun point. Okay, so the gun point is if it is towards the upper direction. Okay, then it is said to be in a correct position. So this will be in a correct position when the vertical circle is towards the left of the observer, right? It is towards the left of the observer. But he said here this is inverted. Okay, so obviously the vertical circle will be towards the right side. Okay, and the bubble also will be down. So if you see here, this is right, but the bubble is up. No, this is not the correct answer. It is left. No, it is not left. The vertical circle is to the right, and the bubble of the telescope is down. Yes, this is the correct answer. So option 3 will be the correct answer, right? So vertical circle is no, it is not left. Fine. Moving further. Straight, parallel and widely spaced contours represent straight, parallel and widely spaced contours. Widely spaced contour indicates a flat surface. Widely spaced indicates a flat surface. A very simple data objective question. Reduced level of a point is the elevation with a reference to. Reduced level is a point with respect. Reduced level, it's not with respect to ground surface. It's not. It generally it is with respect to any reference point, that is a datum surface. So datum surface is nothing but a reference point, nothing but a benchmark. So all these were the wrong answers. So only the datum surface will be the correct answer. Fine. Moving further. The observations from reciprocal leveling are as given below. So leveling readings were given here. So it is concluded that. So again here I am going to take the reading here. So this is station A. So staff is placed here. Okay. Staff reading at the station A. Staff reading at the station A was given here as 1.425. If I go further, the value is given here, that is station B, it is 1.575. 1.575, which is possible when the staff is down, because as the staff is down here, the value will going on increasing. So this is 1.575. So this clearly says that station A is higher. Okay, station A is higher than B. Okay, because not this. If you see these other values also, if you see here from B, the reading here is 0.050, and see here as I am going toward this direction, as see here, the value here is the value is here 1.050. As this is at the higher point, you are going to get the lower value. See here, this is 0.700. So that do mean that clearly I can say that the station A is higher than, this is higher than, not hither than, this is higher than this B, right? Higher than this B, right? Yeah. So moving further. 38. The RL of the floor of a building is 100 and the staff reading on the floor is 1.525, and the staff reading which is held inverted with the bottom touching the ceiling of the hail. Already we have seen this question. So just add these two values so that you are going to get the answer 2.650 plus 1.525. If you add these two, this is 5, this is 7, this is 11, this is 4, 4.175. So 4.175 will be the answer. Simple. Okay. Already we have seen this question. In a contour map, the vertical distance between two consecutive contour lines is nothing but the contour interval. Already we have seen this question. The series of contour lines spaced widely. So widely spaced indicates a flat surface. Spaced widely, that indicates a flat surface. So flat, okay. Closely indicates a steep slope. So closely indicates a steep slope. Equally indicates a uniform slope. So option will be the correct answer, because here widely spaced, that do represent it's a flat surface. Okay. Closely represents a steep slope. Okay. Equally indicates equal spacing indicates an uniform slope. So all the three here, flat, steep, uniform. So flat, steep, uniform, right? Yeah. Moving further. Error due to inclination of a line of collimation in the leveling across a river can be eliminated by reciprocal leveling. So whenever a water body comes in between the leveling area, so obviously we have to go for reciprocal, not ranging, reciprocal leveling, right? Oh my God. So see here, very careful. Okay, so reciprocal leveling will be the correct answer. Fine. Going on for next question. A series of straight, parallel and widely spaced contours represent. So widely spaced contours represents it is a flat surface. Widely spaced indicates a flat surface. So see the 43rd question, a relatively fixed point of space known elevation is called, it's a benchmark. So known elevation point, nothing but a known elevation fixed point is nothing but a benchmark, right? So moving further, the elevation of a benchmark is 100 meters, the backside taken on the staff held vertically is 2.450, the foresight is taken on a point of 2.300, the RL of point A is dash. So the elevation of benchmark is 100, so this is a benchmark, this is of having a 100 value. The backside taken on the staff held vertical, so this is a backside reading taken on this staff is 2.450, okay. If the foresight taken on a point A, so foresight taken on a point A is 2.300, now what is the RL of this point? So very simple, so 100 plus 2.450, this 102.450 minus 2.300 will be able to get the answer. This is 0, this is 5, 4 minus 3, 1, so 102, this is 100.150, 100.150 will be the answer. 100.150 will be the answer. Simple, right? Which of the following arithmetic checks can be applied in rise and fall method? So rise and fall method, summation of backside minus summation of foresight is equals to summation of rise minus summation of fall is equals to last RL minus first RL. Check with this, summation of rise minus summation of fall, last RL minus first RL, no, we have to check this summation of backside minus last RL first RL, yes, summation of rise minus summation of fall. So option 3 will be the correct answer, right? Because we have to take care of all the three. In leveling, height of the instrument is nothing but height of the telescope above the ground, and at the time of observation, no. Height of leveling staff, no. Elevation of line of collimation, yes. Summation of reduced level, no. The only correct answer here is elevation of line of collimation. Permanent adjustments are carried out to set up the level, no. Establish a fixed relationship between the fundamental axis, yes. Focus eyepiece, focus object glass. They are the part of this adjustments, but the point is here to establish a fixed relationship between the fundamental axis. The contour interval depends upon, it is not type of the soil, it is not type of the surveying, it is not the instrument used, only it is the nature of the ground. Simple, that of the education. The backside on a benchmark of 102.50 is a backside, so bottom of the roof. So again here the roof, okay. So the answer, so if you see the diagrammatical way here, if you see this question diagrammatical way here, okay, so this is the backside reading on the benchmark. So benchmark is 102.50, so this is the backside reading taken. So the backside reading taken here is a 2.250, okay, and it is inverted staff reading that is taken at the bottom of the roof. So there is some roof here, so this is a roof, okay. So upon the roof the backside reading was taken here, so the value is 1.515. Now what is the point is asking here, the reduced level of bottom of the roof. So very simple here, just keep on adding all those so that you will be able to get, this is 10 plus 2.250 plus 1.515, you see 102, 103, 104, 105. So the answer is 106.265. Very simple and direct objective question. Okay. Moving further, the benchmark in the leveling is the point of known elevation, not these three options. Point of known elevation. Remember, benchmark also every time it will be having its elevation. So contour lines looks to cross each other in the case of. So generally, it is not a deep valley. It's not a steep hill. It's not a dam of vertical face, it is an overhanging cliff. So if you observe here, the contour map of an overhanging cliff seems to be like this. Overhanging cliff, it will be seems to be like this. They will be getting overlapped here. Contour lines will be getting overlapped here. Okay, cross each other, overlapping. Okay. So in leveling, the height of the instrument is height of the leveling staff, no. The elevation of plane of collimation, the height of the instrument is sum of the reduced level of BM plus foresight reading, no. The height of the telescope above the ground at the time of observation, no. The elevation of line of collimation, it's not plane of collimation, it's line of collimation. See, height of the instrument he is asking about here. So this is the height of the instrument when the reading was taken on the benchmark. So if we can call it like the RL of benchmark plus backside reading. We can't take the foresight reading here. Okay, so backside reading we can take it as height of the instrument. But here nowhere the backside reading was mentioned. But here, if you see, we can also call it as line of the elevation of line of collimation. So this is what the line of collimation is. Okay, so we can simply call it as elevation of line of collimation can be taken as a height of the instrument. Simple. So the line of collimation method for obtaining the reduced levels do not provide a check on. Do not provide a check on. You can see here, line of collimation method. Summation of back sides minus summation of foresights is equals to last RL minus first RL. Okay, so back sides was there here, so not answer. Foresights was there here, not the answer. Change points, no. The only correct answer is here intermediate sides. Only the correct answer is here intermediate sides. The contour lines can cross one another on the map only in the case of an overhanging cliff. Already we have seen this is overhanging cliff's contour map. Okay, so this is the overhanging cliff, the contour map. So the contour map will be getting overlapped. Okay, so they can cross each other. Okay, so these are all the questions that are seen in the leveling and contouring PYQs. Okay, solve all the that means practice yourself very hard so that you will be able to solve all these questions comfortably without having any difficulty. Okay, hope you will be doing good regarding all these questions. Thank you and all the best.
So my dear students, for Ecet 2024 and Ecet 2025, Saimedha Koti Hyderabad is providing maximum concessions in this very week. Offline students gavachu, online students gavachu, online plus offline students gavachu, morning batches, evening batches, day batches, full day batches, online courses with materials gurinchi Saimedha Koti Hyderabad in this very week, guys, in this very week only we are providing the maximum concessions. A concessions evaithe unnayo, concessions ఏ విధంగా ఉంటది, batches ఏ విధంగా ఉంటాయి, with materials, without material, online coaching, total మీకు ఏ డౌట్ ఉన్నా సరే ఆ కన్సెషన్స్ మాక్సిమం ఏమున్నాయి అంటే మనకు మొబైల్ నంబర్స్ ఇక్కడ స్క్రోలింగ్ లో ఆల్రెడీ ఇవ్వడం జరిగింది. సో స్క్రోలింగ్ అవుతున్న మొబైల్ నంబర్స్ కి కాంటాక్ట్ చేయండి అండ్ జాయిన్ ఇన్ ద Saimedha Koti Hyderabad as soon as possible. Don't miss this opportunity of getting the maximum concessions, guys. Thank you very much. In this video series, every single day we are going to be updating subject wise, topic wise, previous Ecet examination questions. I wish you all the best. This is Mohammad Inzamam signing off.